Next week, Wednesday after school, we have the Trig Star competition. So if anybody wants to sign up over here. Trig Star competition is a competition given by the National Surveyors of America or something. So it's basically, you know when we study tri-trig, triangle trigonometry, law of sines, law of cosines, SOHCAHTOA. Remember that stuff? 1/2 AB sine C. So they give you like if you want sample problems I have, okay, but they give you like a diagram, like, okay, it's like a surveyor, here's a block, and then they measure off like a semicircle or something, and then they have this, and then, so you have to compute angles and lengths, that's what you have to do. So you gotta use law of sines, law of cosines, stuff like that. SOHCAHTOA. Yeah, it's a 1-hour test. The school winner gets $100. Like 2 years ago, you guys remember Michael Lau? He was the school winner, he won $100 cash. Last year, I forget who was the winner. You guys, did Mitchell win last year? Do you remember? No, he missed it by like 1 question. And then, if you're the state winner, I think you win $1,000 or something like that. Anyway, so if you wanna, and so that means you gotta use your calculator, right? Law of sines, law of cosines, and they actually give you the formulas too. So it deals with speed. So a lot of people across the state get perfect scores, but then you gotta get it like the fastest. Yeah, so it's like if 2 people have the same score, then you go by speed. Who does it the fastest? So before, there was this girl from Sacred Hearts. She had, I think we had a perfect score, but she had a perfect score, but she did it like way faster. Anyway, so if you're interested, sign up by tomorrow.
What is that?
Don't come in late and start asking questions. Okay, sequence 5 we're discussing today. Where's sequence 5? Right there. Oh, no questions! That means you guys are getting really good. Either that or you're not doing your homework, like period 6. Okay, at least are you guys recognizing the linear recursion? Like on 2B, you gotta, because I told you that's the last problem on the test, yeah? 2B, you recognize that as linear recursion?
Yes.
You wanna do that problem? Okay, let's do it, because this is again, I repeat, but I guess if you're not doing your homework, you're just gonna, even though this is an easy test, you guys are just gonna crumble like cookies. Okay, first of all, how do I know that this is linear recursion? Anytime you multiply the previous term by something and add or subtract something, that's linear recursion. Okay, let's write out the first few terms. Actually, you only need the first 2, but let's just write out. 16, to get any term in the sequence, you multiply the previous term by half and add 2. Multiply this by half, add 2. Multiply this by half, add 2. And then after that, get fractions so you guys have a hard time with that. Okay, let's just do it for funsies. Multiply this by half, 3.5 add 2, so you guys can do it. Actually, I did. Okay, but what's the explicit formula? That's what I want to know. What's the explicit formula? What's the formula going to be? Were you guys here yesterday? If you keep multiplying the previous term by a half, it's going to be some kind of geometric sequence. Whatever number you see there, that's what you put in the parentheses there if you want a recipe. But then, since you keep on adding 2, it's going to be like a mutation of it, so then you have to multiply it by A and add B. So if you don't remember this, it's going to be a -8 on the test. Right there. Now, how do I figure out what A and B are? Yeah, you use the first 2 terms. If you plug in 1, you get this. If you plug in 2, you get the second term of 10, right? And then you solve those equations. So if I plug in 1 for n, you get 1/2 a plus b, that has to equal to the first term. If I plug in 2 for n, you get 1/4 a plus b equals the second term, and then you just simply solve those two equations. So subtract, this minus this. This minus that. You guys can't even subtract. 1/4 a equal 6. Therefore a equal 24. Plug it back into one of these, okay, right there. So b is 4. So the explicit formula then will be 24, 1/2 to the n plus 4. That's your explicit formula. It's kind of easy, but you have to remember that it's linear recursion. And I think I told you 2 days in a row, it's gonna be the last problem on the test. I'll tell you again tomorrow, but how many of you are gonna miss it still? And the first 15 problems are gonna be all limits. You guys have these down yet? Because again, you got nothing up there. Just F.
Okay.
FJK.
Oh, now they.
M. 3 to 3. Oh.
3.
Oh, we
JK.
still got. I wanted to show you something because it's gonna be. This might be on the test. Okay, 1F. Okay, like I told you, if you don't know anything, what do? You plug in numbers like 1, 2, 3, 4, 5, 6. Did you guys at least do that? If not, just go home, cook rice already. Anyway, what does this do? What does that thing do? What happens when you plug in 1, 2, 3, 4? What do you get? -1, 1. -1, 1. This thing just makes it alternate. This thing is equivalent to this, right? -1, 1. But I just write that because I want you to know trigonometry. That's why. Okay, and what's the limit of this part right there? N over n plus 1. How do you find the limit of that? What are you doing with your phone, Hanoka?
Sorry. That's for the AP exam thing.
So why do you need your phone?
Text my mommy.
Yeah, free period, not during class.
Sorry. This
I don't want sorry.
too soon.
I want money. $20 bill right there. Okay, n over n plus 1. What is the limit of that? If the degree of the top and the bottom are the same, you look at the coefficients. 1. So these numbers here are getting closer and closer to 1, but this makes it go negative, positive, negative, positive. So what do you think the limit is? It doesn't exist. Because the negative numbers are getting closer to -1, and the positive numbers are getting closer to +1. So like if you were to graph it, okay, here's 1. I mean, if you were to graph it, it would look like this. Right? The negative numbers are getting closer to -1, but the positive numbers are getting closer to 1. But it's not getting closer and closer to some number, so that's the limit doesn't exist. Because it's oscillating back and forth. Okay, Jay. Oh. Happy April 1st. When you have a number raised to the nth power, what kind of sequence is that? It's geometric. All you have to, this is the second easiest one that you're going to get. You just gotta look, does it fall in this region, or that region, right? If it's here, infinity. There, 0. There, it does not exist. Now, what is tan inverse pi over 3? That's a number. I know I just gave the answer. What's tan inverse root 3? It's pi over 3, right? Tangent of what angle is root 3? Pi over 3, right? Now, is pi over 3, what region does it fall in?
Greater than.
Yeah, it's over here. Bigger than 1, the limit is infinity. Whenever you have a number to the nth power, that's what you gotta do. You gotta figure out where that number is. That's the second easiest one. The first easiest one is like this one. When you have a rational function, you just compare the degree of the top and the bottom. Those are the two you gotta look for. Those are the two easiest ones. Okay. And there we go! Go to your room! No dinner! Give me your phone! Look, right there! What's the limit of that thing right there? If the degree of the bottom is bigger than the top, 0. So this gets closer and closer to 0, which means that gets closer and closer to secant 0, which is 1, which gets closer and closer to natural log 1, which is 0. What's the problem? We didn't know secant of 0 is 1. Was that the problem? I went home yesterday, I hear these two students from trigonometry, they quizzing each other on the trig values. They knew secant 0. How come we don't know secant 0? Why am I even asking you a question? Why pretend you're going to even answer? M, 10, didn't I give it? Go to your room. We did this the very first day. Do we know what the graph looks like? This is the third easiest one, people, when you just know what the graph is. What does the graph of tan inverse look like? Well, let me draw it again for like about the 10th time this year. There, that's what the graph looks like. So what happens as the graph goes out to the right? The y coordinates are getting closer to pi over 2, because that's the horizontal asymptote. So the third easiest category is, if you know what the graph looks like, you just think of it. It's the part that I have a hard time with inverse street graphs, then go home then. Come on, this is supposed to be branded into your brain by now. And then number 3. Number 3, complete the recursive formula. Okay, let's try to save some time. Or give me the first few terms. 1,
Negative 2/3.
negative 2/3, positive 3/5, negative 4/7, positive 5/9, negative 6/11. I see a pattern, Mr. Park. Oh, that's the pattern right there. Okay, but you gotta write a recursive formula and it's addition. So, what did I tell you? Did you do this on today's quiz? Because if not, I'm gonna go crazy. I'm gonna snap. It's gonna fit a gigantic 0 on the top. If I don't see that, that's not right. I don't know if I saw you do it yet. I'm gonna pretend you did. Okay, all you gotta do is fill it in, and if you do it correctly, there will be a pattern here, so you can fill in the general case, which is this. Like I told you, on the test, gonna have 2 of these. One's gonna be kind of doable, the other one you're gonna have to like use your mathematical prowess. Okay, fill in these numbers. Yep. Yep, Miranda. What do I have to add to that to get that? I'll give you a hint, negative something. You get the easiest one. Okay, next one, Zhang, read it off your paper. What's so funny about that? How long does it take to read something off your paper? Over. Okay. Next one. Miyaoka. Yeah, that's what I'm talking about. Read it off your paper. And then the last one, Oyadamari.
71/63.
Okay. Everybody got that?
Yeah.
I got it down. Now you gotta look for the pattern. Now the first thing you notice, it goes negative, positive, negative, positive. How do you make it alternate? Negative 1 to the n or n plus 1. But remember, this is a recursive formula. You plug in 2, you want it to come out negative, right? So n plus 1. Because then if you plug in 2, you get negative 1 to an odd, which is negative, right? Okay, now look at the top numbers. 5, 7, 19, 41, 71. Now yesterday's one, it was arithmetic. Is this arithmetic? 5, 19, 41, 71. Is that arithmetic? Does it have a common difference? No, see how things are getting kicked up a notch? So, it's not arithmetic, it's not geometric, so either you break it down, or we gotta look at the differences like today's quiz, right? Can anybody break it down?
Square numbers plus odd.
Square number?
2 squared plus 4 squared. Of the even square numbers plus the odd numbers. 2 squared plus 1, 4 squared plus 3, and 6 squared plus 5.
Oh, okay, so Chai said, what is this?
Even square numbers.
So, 2 squared plus 1,
4 squared
4 squared
plus
plus 3,
6 squared
6 squared
plus
plus 5, 8 squared plus 7. Is there a pattern to that, or these are just random numbers? There's a pattern, so you gotta describe it. Okay, so how do you generate the numbers 2, 4? This is not the pattern I thought of when I did it. 2, 4, 6, 8. How do you generate that? That's arithmetic. What's the common difference? 2, 4, 6, 8. We don't even know that. 2n, and then you adjust. If you plug in 2, you want to get 2. If I plug in 2, you want to get 2. Minus 2. So that's squared plus, how do you generate the numbers 1, 3, 5, 7? Again, it's arithmetic. So what? Common difference 2, and then you adjust. If you plug in 2, you want to get 1. What's 2 times 2? 4. What do I have to do to 4 to get 1? Minus 3. Okay, that's good, but that's not what I thought. See, but he broke it down, that works. This is what this is what I saw. I saw this is 2 times 3 minus 1. 4 times 5 minus 1. You guys see a pattern now?
Yeah.
6 times 7 minus 1. 8 times 9 minus 1. That's the pattern I saw. So how would you write that? Okay, so this is correct. It works. Okay, but that's not what I saw. I saw this. So how do you generate the numbers 2, 4, 6, 8? So 2n and then adjust. If you plug in 2, you want to get 2. So minus 2. Okay. And then 3, 5, 7, 9. Hey, arithmetic, common difference 2. So 2n and then adjust. If you plug in 2, you want to get 3. Minus 1. And then minus 1. And you'll find that it's exactly the same as the one Chai came up with, right? Now, what if you can't break it down at all? Then you look at the differences. 5, 19, 41, 71. What are the differences here? 14, 22, 30, 8, 8, 8. Oh, it takes 2 levels. So you know the formula is going to be quadratic. You know the formula is going to be an squared plus bn plus c. And then you can do the 3 equations, 3 variables thing that you did on today's quiz. Hopefully by now you guys can break down a little bit, right? Okay, then just do this all the time. But you got to be careful. You got to start by plugging in 2 now. If you plug in 2, you get 5. If I plug in 3, you get 19. And if you plug in 4, you get 41. You guys understand that? It's a recursive formula. You start by plugging in 2. Okay, now what about the bottom? Okay, the bottom is pretty easy. Look at the bottom numbers. How did you even get these numbers? From the least common denominator, right? So what? 1 times 3, 3 times 5, 5 times 7, 7 times 9. Is there a pattern to that? Duh. Yeah, so how do you generate the numbers 1, 3, 5, 7? Hey, it's arithmetic, common difference 2. So 2n, adjust. If you plug in 2, you want to get 1. Plug in 2, you want to get 1. And then how do you generate the numbers 3, 5, 7, 9? Hey, arithmetic. Common difference 2, 2n, and then adjust. If you plug in 2, you want to get 3. Minus 1, and there you go. So we're going to have 2 of these in the test. What happens if you scroll both up? Minus 16. Okay, one last thing. Oh, look at the time. Boo! Okay, I wouldn't be surprised if I saw this on the test. You You guys ever saw this game before? This is called the Tower of Hanoi. Okay, you guys know how to play this game? Okay, the rules are you can only move one at a time and you cannot have a big one on a small one. And the objective of the game is to get this pile to a different problem. Okay, so you can move one at a time and you cannot have, like this, illegal. You cannot have a big one and a small one, so you gotta do that, and then what? You do that, and then you move this one here, and then where do I put this one? And over there, and then you do that, and then see, now it's starting to take shape, right? And then you just keep on going until this pile is at a different problem. Okay, now there's a legend associated with this from Buddhist monks. And because this one has, I have 7 discs right here. But Buddhist monks said if you had 64 discs and you could move one every second, then when you finish the game, then that's the end of the world. So if you had 64 discs, you could move one every second, which is kind of hard to do. Then when you finish the game, that's going to be the end of the world. So that's a good math problem. How long would that be? If you had 64 discs, you could move one every second. How long would that take? It's a good math puzzle. So how would you even begin to do this? Well, every year students say, oh, I would just build one. I would make one with 64 discs and try it. You know how long that would take? We're going to find out it's a very long time. You know what's an easier way? Look for a pattern. Start with the simplest case. What's the simplest case? 1. If you had 1 disc on there, how many moves would it take to move it to a different problem? 1. Let's try it. You're right. 1. We're looking for a pattern here. Okay, now what if you had 2 discs? How many moves is it going to take? 1, 2, 3. You guys see the pattern yet? What's the next one going to be? 5. You can't tell a pattern with just 2 things. They think you guys are so hot, yeah? Okay, what if you had 3 discs? How many moves is it going to take? 1, 2, 3, 4, 5, 6, 7. You see the pattern? What's the next number going to be? So it is add 2, add 4, add 13, then the next one. Maybe, I don't know. Okay, now, let's be smart since we're honors. Without actually doing it, you see these top 3 discs? How many moves is it going to take to do that? And don't say 1, because you're going to move only 1 at a time. How many moves does it take to move 3? 7. How many moves does it take to move the bottom one? 1. And then how many moves is it going to take to move these 3 on there? Another 7. So 7 plus 1 plus 7. We can't even add that. 15.
Oh, it's recursive.
Exactly. This is a recursive sequence. So now we're smart, right? We're honors. How many moves is it going to take to move 5? Well, how many moves is it going to take to move the top 4? 15 plus 1 plus 15. So what's 15 plus 1 plus 15? See, now we don't even need the game anymore, because what's the recursive formula? You multiply the previous one by 2 and add 1. That's the this is the recursive formula. an equal 2an minus 1 plus 1. That's the recursive formula. And the first term is 1. Okay, but we need to get up to 64. Okay, so what's the next one going to be? Multiply this by 2 and add 1. Okay, 7. Multiply by 2 and add 1. So getting up to 64, can you still, I mean, see, that's still going to take a long time. So a better way is to write the explicit formula so we can just plug in. Okay, so what would the explicit formula for this sequence be? We're running out of time here, got 1 minute. I believe I gave it on one of the homeworks. So if you did your homework, you should recognize these numbers. I'll give you a hint since we're running out of time. These are all 1 smaller than numbers you should know. This is 2 minus 1, 4 minus 1, 8 minus 1, 16 minus 1. 2 2 to the n minus 1. See? 2 to the first minus 1. 2 to the second minus 1. 2 to the third minus 1. 2 to the fourth minus 1. Wasn't that on the previous homework? I don't know, I didn't do that over here. That was sequence 3! That was so long ago. So this is the explicit formula. So if you had 64 disks, how many seconds would it take? 2 to the 64 minus 1 seconds, if you could move one every second. Now, you guys have no idea how big this number is. We're running out of time, I'll just tell you. This is over 585 billion years. If you were to convert it to years. That's how long it would take. So those of you who would build one and see how long it takes, well, that's how long it's gonna take. And that's only assuming you can move one every second. Some of you thinking, yeah, that's not that long. What are you talking about? The age of the Earth is what? Between 6 and 10 billion years? Right? The age of the Earth is between 6 and 10 billion. This is 585 billion years. So the lesson learned. Look for a pattern. Start with the simplest case. Write a few cases down and see if you can see a pattern. Don't build a model.